welcome back to MathSpark. We'll be working on long division. Now, this is an add-on to our long multiplication lesson with some little long addition in there as well. That you should probably see before this. And what this is basically, this long stuff is about, is we have these addition, this subtraction, multiplication, division, things like this, but all our little methods become really hard to use when you get really big numbers. So mathematicians have figured out that if you pretty much stack them on top of each other and do it one by one, you get the same answer. That's not exactly the technical way this works, but that's more or less the gist. So today we're going to be working out long division. Now long division works, let's say you get some huge number, like 270. You want to divide that by 9. We're thinking, well, these numbers are huge. It's going to take forever for me to chart that out and cut it up into pieces. Well, now you don't have to do that anymore. What you would do to set up long division here is you get your 270, your first number, and you put a little half box around it. And then you put the 9 right next to it. And this is what a long division problem looks like. And what you do here is you see how many times this number can go into this number. Now, this number is actually greater than 2. So you have to skip this and put a 0 there, but since this is the beginning, you don't really have to put that, but you can for purpose sake. And you move on and you make these two go together. So if the first one is smaller, like you'll find a lot, you move on and smush these two together into 27. So 9 goes into 27 3 times. You multiply 9 by 3, you get 27. So you put a little 3 there, and then you just put it down there. You can work that out. It's exactly 27. So you put your 3 there, and then you have the 0 there. Once you have the 0 there, you just kind of plop a 0. Once you're just all out at zeros, you just plop another 0 there, and that's that. So now you know 270 divided by 9 is 30. You didn't have to graph that out and cut it up into pieces or anything. And the reason that I brought up the subtracting it out is, say you have something that isn't exact. Like, let me think of something. How about 160 divided by 7? I don't know if this goes evenly or not. So you get 160, and you're about to divide this by 7. Now we have to skip over to our 16, but 7 doesn't go exactly into 16. So you have to find the nearest number to it that is lower than it. So the nearest number to this is 14 that goes into 7, because 7 times 2 is 14. If you multiply by, say, 3, you get 21, which is above it and is farther away than 14. So you see what number you can multiply to get the closest number to it that's lower, or preferably an exact number. But a lot of times that won't happen. So you put your 2 here, symbolize that you've multiplied by 2. And under here you put this 14 that you've gotten out of it. And then you subtract this. And this is a long subtraction part of this. Basically, the way long subtraction works is you stack them on top of each other like long addition and do the down thing, except this time you do it subtracting. So 6 minus 4 is 2. 1 minus 1 is 0. So then you say, well, this is as lonely 2. So you again do that whole skipping over thing, because the 2 is lesser than the 7. And you can just bring this 0 that's right here down and skip over it and make it 20. And then 7, the closest thing you can get using 7 is again 2. So you get your 14, you subtract, and you get 6 this time. And now we've moved on past, there's no more zeros here. So what we're going to do is move on into decimals. Now decimal is pretty much, you probably already know this, but a decimal is in between two numbers. So you have like 1, and then you have 2. And in between that is 1.5, or 1.5. Sorry. And what a decimal represents is that in between. So 22, because we've gotten past this, turns out this didn't go in evenly. Probably should have seen that coming. But anyway, we gotten past this last 0, so now we put our little decimal point here and just keep going along. We make up a 0 and bring it down here, because 0 equals nothing. So you can pretty much pull 1 out of thin air. Not exactly, so don't take my word for that, but more or less, yeah. So you have your 60. The closest thing you're going to get to that, let's see, and it doesn't hurt to go over to the side and kind of test things out. So maybe you think that it's 7 times 6. That's as close as you can get to this. So you multiply 7 by 6, you get 42. You realize, whoa, I've got a long way to go. So you step it up a little bit. How about 7 times 8? What do you get with 7 times 8? Well, 7 times 8, you get 56, right? Yeah, 56. Sorry. And 56 is the closest you're going to get to that. So you put a little 8 there, and then 56. And you make your 4, and you keep going on, and I figured out this is a really bad example of this, because we're just kind of keep adding decimals. But hopefully, you get something that ends, or if you keep repeating, you can just kind of give up if you're rounding to the 10th or rounding to the 100th, which is different type of decimals. So say you have 1.125. This is equivalent to 1/8. So this is the 10th. This is the 100th. And this is the 1000th. Notice how there's a TH at the end of that. So you can distinguish it from one above the decimal point, tens, hundreds, thousands. You may be thinking, why do you start with 10? Shouldn't you start with the ones? Well, the tens go to 10 because you have 0.1 all the way up to 0.9, and then you start over with your another number. So 10 of them make up one number. And over here, 100 of these make up one number. And 1,000 of these make up one number. So that's where you get the 10th, 100th, and 1,000th. So whenever you see something like, say, round to the nearest 10th, what that means is round to the nearest first decimal point. So that's good to understand. So you can round to the nearest 10th or 100th or whatever you want to do. This was a really bad example because it's not an exact thing. See if I can think of an exact thing. Because we're about to do some practice. Yay! See if I can think of something exact that's still at the same time hard. Let me think. Well, how about this? 233 divided by, no, scratch that, 333 divided by 3. So try that out for size. Just get a piece of paper or a pen. Remember, this is a 3. Sorry about that. You might want to write that down because you probably can't distinguish that. And so that's 333 divided by 3. It's a bit repetitive, but just get out a pen and paper, work it out. If you don't have a pen and paper, that's okay. But it really helps to do this because arithmetic is all about practicing. You gotta practice, get it down. So we're gonna work on this. I'm not gonna give you the most amount of time, but if you need more time, especially with long division, because this tends to be time consuming, just pause the video. So okay, hope you like my little jig. We're going to get on with this problem. Now, some of you probably figured out that this was pretty easy. That was mostly intentional. It was to prove a point. Now, you have your 3, and this 3 is equal to this 3. They're not lesser than each other. So you don't move on to 33. Some of you that maybe probably did that. So you don't move on to 33. And so you just multiply 3 by 1. Then you get another 3, and that's 0. And then you just drag down this 3. And then you do it again. Another 1. Another 0. Another 3. And then you do it again. And you get another 0. Now, if you get to the end of it and you do, in fact, have a 0, you stop there and don't go into the decimals. If you don't have a 0, then you add your decimal point and keep going. But yeah, the answer is 111. You probably saw that coming when they were all so repetitive. So that's the practice here, and we're gonna move on a little bit to a little kink in long subtraction that I want to make sure I get down. Let's say we have 245 minus 167. So again, you just do down column by column, but what you meet here is 5 minus 7, which is a number lesser than 0. So what you have to do here is borrow a 10 from this other thing. because remember 45 is the equivalent to 40 plus 5. So what you do is you just borrow a 10 over here. So instead of this being a 4, you make this a 3, but then you can add the 10 over here and make that 15, and that equals the same thing. So then 15 minus 7 is 8, and then you would experience the same thing over here with 3 minus 6. So you just borrow it again, and make this a 1, and make this a 13. You get 7 there, and then you get 7 there, and then 1 minus 1 is 0. So this equals 78. And another thing is that, say you have 201, minus 89. So you have this 1 minus 9, so you try and go and round over, but this is a 0. You can't borrow anything from that. You scratch that out, make that a 9, and then move over to this one and make it 1. And the reason for that is, say you have like 200, and you subtract 1 away from that, you don't get 201 or anything like that. You don't get anything in the 200s. You move down to 199. So what you're doing here is you're trying to take a 10 from here, but since there's no 10 to take, you take 100 away, but then add 90 to this, which is the equivalent of taking 10 away. See, there's logic behind that. And so then you can work out your problem here, because now you have your little 10 you can borrow. You get 2, and then 1, and then whenever you don't have something here, you just assume this is a 0 and bring down your 1. So then you get 112. And those are just nifty little things of subtraction. And so that'll bring it into our long division tutorial. But again, you need to practice this and practice this and practice this, because that's really the only real way you're going to be able to learn this arithmetic. Because I can teach you how to do it, but that doesn't mean you're instantly going to know how all this works. You've got to practice it and kink it out, and make sure you understand this for algebra. And so this has been our long division / long subtraction tutorial, and I will see you guys next time.